Now we are going to discuss Euler's equation along a streamline. Right. What is the meaning of streamline? We have already studied that in any fluid region, if we draw a line, and for this line, if we draw a tangent at any point, and if that tangent gives us the velocity at that point, then this imaginary line is called streamline. So a fluid particle is taking this path, right. So a fluid element which is moving here, it is enclosed here with the help of this control volume. So we have defined this control volume of size delta s in this direction. This distance is delta s, and this perpendicular cross sectional area is delta A. Cross sectional area of this control volume is delta A. So we will write Newton's second law of motion or Euler's equation for this control volume. For this control volume, what is the pressure acting on this face? Pressure acting on this face is equal to pressure multiplied by corresponding area. So this is the net force acting perpendicular to this face in the direction of S. So P into delta A. What is the net force acting on this face in this direction? Because pressure force always acts in such a manner so that it compresses the fluid element. It is P plus del P over del S. Del P over del S is gradient, pressure gradient in S direction. So P plus del P over del S multiplied by delta S multiplied by corresponding area, and area of this parallel cylinder is delta A in a cross section. The length of this control volume is delta S. Since we are considering a Euler's equation, so we are not considering the shear force being applied on the surface, on this surface, similarly on this surface. Now we are not considering any acceleration here, flow is a steady flow, but there will be one body force. What is that body force? That body force will be acting because of the weight of fluid element. This weight of fluid element will act through Cg of this fluid element in a downwards direction, and magnitude will be weight. So weight is equal to weight density, weight of this control volume is equal to weight density of fluid multiplied by volume of the fluid element. Volume of the fluid element is delta A multiplied by delta S. This is acting downward, and if this angle is taken as alpha, then we can write the momentum equation in the direction of S. So if we want to write momentum equation in the direction of S, then what we have to do? We have to write the forces acting in S direction is equal to rate of change of momentum in S direction. So what is the force acting in S direction? Force acting in S direction is equal to this force P into del A, and this force minus, right. So we have this force, this minus this will be equal to P will be cancelled, and it will be minus del P over del S into delta S into delta A, this term. This is acting in negative S direction, right. So this is minus, and weight component will also act in this direction, that is also minus S direction. So that's why it is taken as minus rho into G del A del S into cos of alpha, because it will have one component in this direction which will be equal to cos of alpha. So this is the net force acting on this fluid element in S direction. Now we know that this force acting on this fluid element in S direction is equal to rate of change of momentum in S direction. rate of change of momentum in x direction is equal to mass of the fluid element. Mass of the fluid element is rho del S into del A. Since fluid is considered as a incompressible and steady, that is why this may be written outside the differential. Rho del S into del A, this will be equal to mass into dV over dt, right, dV over dt. So, if we want to replace this cos alpha, then with the help of the trigonometry, we can relate this cos alpha to delta z and delta s, right. So, if we can draw perpendicular here and if we can draw a horizontal here, then this distance is delta s and this distance is delta z, right. So, cos alpha may be written as limit delta s tends to 0, delta z over delta s, this may be written as dz over ds. So, after defining the cos alpha with the help of trigonometry, this formula, which is on the basis of momentum principle, may be written as rho dV over dt is equal to minus del P over del S minus rho g dz over ds. Now, this rho dV over dt may be expanded with the help of the total derivative, which we have already studied. This may be written as del V over del t plus V del V over del S, right. So, it is in the direction of S. Since we have only one direction, so we have V del V over del S is equal to minus 1 over rho, this rho is taken on this side, minus 1 over rho del P over del S minus G dz over ds. So, Euler's equation along a streamline can be written in this form. What is this? This is acceleration and this is the net force, right, per unit mass.